Hi there and welcome to this video. We're going to talk about this algebra question requested on Wyzant, looking at graphing transformations. Now, this one is specifically on linear. And how do I know this? Well, because you pretty much can tell by the equations given, and that's what you're definitely learning more and more throughout your algebra course studies. You're going to be seeing that, different types of equations or functions are given different names, right? And so in this problem, we're talking about, or really being asked to find the transformations, which sounds like we're just listing them out, but I will show at the end, towards the end, the graphing of these two. And we're going to use Desmos because, it's a video and it's much more convenient. But we're going to find the transformations that we see in this transformed graph. Let's call it the transformed equation or graph. And where is it transforming from? It's transforming from what we call the parent function of that type of function, which again is linear. And I know it's linear, just a recap, review on this. I know it's linear because the leading variable or leading term with the variable x has an exponent or power or degree of 1. So if any of those terms sound familiar, then that's great. But maybe you haven't gotten to the point of really sifting through polynomials. So I'm just kind of jumping ahead on that point then. But just want to give you a clear understanding as to why we call this linear versus any other type of function. So given the problem, given the information, again, it sounds like we're just going to list out these transformations in this equation. And that's what we're going to start moving into now. So when I look at this equation, let me just say first, I can count 3 transformations. Let me go ahead and highlight them as we see it. So we have this one up front, and it looks like it's going to be changing the slope, right? Then we have this one, and then we have this one. These last two towards the end has to do with how the entire graph has translated or moved across the coordinate plane. So when we look at it in this equation, that's how you have to think about it. Now, this chart right here is phenomenal. This is one of my favorite images or figures that really helps us to organize and recognize what type of transformation is, what it is, right? And how can we look at it in different ways? So obviously we have looking at the equation as a way to identify transformation. But one of the other little details that I like here is actually what's happening with the coordinate points. Okay, so like I said, I counted 3 of them, and I'm going to start with the back end. Okay, so let's just first look at the transformation with the 4. All right, and the way that it's situated, which you can tell with the chart here as well. Notice the first column here on function notation. Anytime you have some number adding or subtracting from what they're calling like the entire function. So let's just kind of block off a part of it to represent that. So this would be like the f of x they're saying in the chart. So 4 is adding to the rest of it. And that's what we're going to call our vertical translation. You may also use the word or heard the word shift. So I'll write that down as well. And this is going to be up 4 units, okay? And that's all to that. And what we're doing with the points then is we're moving every single coordinate point up by 4 through the y coordinate, right? So all in all, the entire graph is shifting up, okay? I'll make sure, like I said, when I show the graphs, I'll demonstrate each transformation one by one. Now moving towards the left, moving up to the front of the equation, we're going to look at the next one here, the -5. This is one of those interesting situations. So unlike the vertical translation, which, what you see is what you will see on the graph, -5 does not represent left direction. It's actually going to be the opposite. Okay, so this is going to be our horizontal translation or shift. And this is going to be to the right. Okay, so on our chart here, we can see that that's what's actually happening. So when we have any value, and this kind of goes with anything, okay? But this is especially the case with linear functions. Anytime you have a value that's grouped with x, then that's going to represent a horizontal effect, okay? And oftentimes it's going to be kind of the opposite of what's shown, all right? And so for horizontal translation, when it's negative, we see it's to the right, and then we see how it's actually playing out in the coordinate points. Also, you can just, what would it be? Trying to find the words for this part. It would be like if you were to algebraically work through the equation, you can solve for x in this case as it relates to that translation, that horizontal translation. You know, for example, if you just isolate x minus 5, just that group, and let's say you set it equal to 0. This may be one way to show why it's actually positive 5. Okay, so when we solve it, we see that 5 is actually positive as an x value. So all in all, the whole entire graph is going to be shifting to the right based on that. All right, this last one is quite interesting. And this is going to be associated with these last two at the bottom. All right, and I'm not going to get too much into this. I'm just going to point out what it is and make a few comments about it, but not to make this a whole lesson. But 3/4, we got to first figure out, okay, well, which type of effect is it? Is it vertical or is it horizontal? Because notice, let me use my highlighter. Okay, you have 4 options that this value can represent, this number. Okay, so the first question is it vertical or is it horizontal? And based on the positioning of that number, it looks like the variable a here, representing any number that produces a vertical effect. So the way that it looks, again, let me just do some grouping off here to showcase that. 3/4 looks like it's multiplying with the entire function or the rest of the function. And another way I like to say it is, again, if it's grouped with x, it will have a horizontal effect. So if it's not grouped with x, like the vertical translation, notice that it's not in the group with x, then it's going to be a vertical effect. So in this case, we're going to definitely go with it's a vertical effect. Now we have to decide which type of vertical effect on the slope. Again, that's why I said in the beginning, it's going to have effect on the slope. It's changing the slope. So it's either going to be a stretch or a compression here. Now, horizontal has the same thing, but it's just going to look a little bit, well, let me say it's going to be written differently in the equation. So when it's a vertical effect, again, what you see is what you get, right? If it's a large number, in this case, for it to be a stretch, a has to be greater than 1. Notice the absolute value bars. That means, you know, if you have a negative value, this still is representing greater than 1. So just the number itself, don't worry about the sign too much. The sign is more or less talking about reflection at that point, if we were to have a negative sign. Okay, so if it's larger than 1, the number, then we're going to call that a vertical stretch. If that number, though, is between 0 and 1, in other words, if it's a proper fraction, small number over big number, then this means we have a compression. And what does this look like of the graph? If it's a vertical stretch, we're stretching the graph vertically. If it's a compression, we're compressing the graph vertically, okay? And it's going to be kind of hard, I would say, just in my opinion, it's going to be kind of hard to really see this more with linear functions than other functions like a quadratic. With a quadratic, you can really see the difference. Let me just show real quick an example. Let's say you have, here is our parent function, x squared. And if you had a vertical stretch, it would do this, right? Stretching up and down. If it's a vertical compression, it will look like this, more shallow looking, because it's pressing in inwards like that. Okay, so you know, maybe you'll probably see it better than me with the linear function. But yeah, I think it's more or less more visible with other types of functions. So to wrap this up, we have the final transformation, which is a vertical stretch by a factor, because this is like a scale factor, right? A factor of 3/4. Okay. And that is probably it for the answering of this question. If we had to look at it as a graph, let's go to the decimals here to our graphing calculator. We're going to plug in, and I'm going to definitely, just show the comparison here, but we're going to plug in our parent function there. So there you see it's a simple one-to-one slope with its y-intercept through the origin. Then we have our transformed graph, and I'm going to start with the back end. Let me put parentheses around it. Okay, so first we see that the 4 has moved or has made the graph move up, all right, from 0 to 4. So that was the first one we talked about. Then we're going to see that it shifts to the right 5 units. It should land on +1. So there it is. Okay, so first we had moved it up, but then when we shifted to the right, that actually changed the y-intercept. Okay, so now it's at -1. Now we have the final transformation. It should make it sorry, I just realized something, and I had this written in my notes correctly. So you probably noticed this, and I'm glad if you caught it early and you were like, no, 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 it's compression. It is compression, right? Because it's 3/4, meaning it's between 0 and 1. So I am so glad I caught that before I went into this display. All right, so let me go back up here and type out 3/4. And notice how it looks like a shallower slope. Okay, the red being the parent, right? It's a little bit steeper. It's simply one-to-one the slope, but it's a steeper slope than the new transformed graph with the slope of 3/4. Okay, so with that being said, our graph then has kind of tilted a little bit, right? And it's you could say it's moving at a slower rate if we were to talk about the physics of it. Okay, and so that is our transformed graph, right? And that is it for this question. I hope you found it helpful. Again, I'm so glad that I fixed it there before we finalize things in this video. But definitely let us know if you have any questions, and we look forward to helping you further with your studies.